Arithmetical rules and laws. The most important arithmetic properties are the commutative laws of addition and multiplication, the associative laws of addition and multiplication, and the distributive law, which connects addition and multiplication. In this topic, things we shall learn and explore include the orders of operation, PEMDAS, arithmetic properties such as commutative, associative, and distributive laws, identities and inverses, number bases and converts between them, converting between units, adding and subtracting binary numbers, and ratios and proportions. To work out a question like the following 3 times 6 minus 4, you use PEMDAS, where P represents parentheses, E represents exponents, M represents multiplication, D division, A addition, and S subtraction. So therefore we will do multiplication first, since the hierarchy goes from P to S. So we said 3 times 6 is equal to 18, and then we subtract 4 from that 18 to get 14. Commutative. The order in which you add or multiply two numbers does not matter. So if you have 3 plus 5 equals 8, switch it around, 5 plus 3 is also equal to 8. 6 times 3 equal to 18 is the same as saying 3 times 6 is equal to 18. In other words, A times B will be equal to B times A, and A plus B will be equal to B plus A. Note well that subtraction and division are not commutative. 6 minus 2 is equal to 4, but it's not the same as 2 minus 6, which gives us negative 4. 18 divided by 3 is equal to 6. It is not the same as 3 divided by 8, which gives us 1/6. Associative. Associative deals with the order in which you add or multiply three numbers, and it does not matter. For instance, if you have 3 plus 5 in brackets plus 9, it will also be equal to 3 plus in brackets 5 plus 9. Both ways will give you the numerical value of 17. In general, if you move the brackets around, you get the same thing. So if you have A plus B plus C with the brackets around B plus C, and then you move the brackets around A plus B, you're going to get the same answer. If you have A times B times C with the brackets around A and B, equal to A times B times C and the brackets are around B and C, you will get the same number. Associative deals with the movement of brackets. Note well that subtraction and division are not associative. 9 minus 4 in brackets, subtract 3, is not equal to 9 minus in brackets 4 minus 3. 9 minus 4 will give us 5, subtract 3, that will give us 2. If you subtract 3 from 4, you will get 1. 9 minus 1 will give us 8, two different numbers, or two different answers. And remember we talked about PEMDAS, we spoke about PEMDAS, so we have to work out what's in the brackets first. Look at this one, 9 divided by 3 in brackets divided by 2 is not equal to 9 divided by, in brackets, 3 divided by 2. 9 divided by 3 gives us 3. 3 divided by 2. That's the answer. For this one, you will end up with 9 times 2 over 3, which gives us 18 over 3, which will be equal to 6. Distributive law. This property is used for long multiplication. For example, 6 times 23. If you multiply 6 by 20 plus 3, which is in brackets, and you distribute that multiplication across the addition sign, you will get 6 times 20 plus 6 times 3 to give you 120 plus 18, which gives you a total of 138. Please note that 6 times 20 plus 3, that is in brackets, is also the same as writing 6 open bracket 20 plus 3. In general, the distributive law states that A times B plus C in brackets will be equal to AB plus AC. Examples say whether A through J is commutative, distributive, or associative. Note well that you would use the same laws from before. Again, commutative deals with the addition or multiplication of two numbers, and so they can be flipped around and give the same answer. Associative deals with the multiplication or addition of three numbers, where the brackets can be placed anywhere and you still get the same answer. Distributive deals with the multiplication of numbers that are either being added or subtracted in brackets. So let's try these again. I'll do the first 3 for you. So let's work together, and then you do D, E, F, G, H, I, J by yourself. So if you have 7 plus 9, if we flip these around, we get 9 plus 7, and we get the same answer. 7 plus 9 is 16, 9 plus 7 is also 16. So we say that this is commutative. Remember, commutative deals with the flipping around of numbers, and once they're flipped, you're able to get the same answer. One way to determine whether these questions are either commutative, distributive, or associative is to imagine that they are letters. And so if we say that 7 is A and 9 is B, we can write A plus B. And we see here that this looks like what we saw under commutative, where we say B could also add to A and get the same answer. So we have A plus B, and then therefore B could be added to A. So A plus B is therefore equal to B plus A. And this one as well, we could look and see that if this is A and this is B, then we could have A times B is therefore equal to B times A. So these two are commutative. Now if we draw this one out now and just label this as A, B, and C, we see here that we have A times, in brackets, B plus C. And if we go back, we could look for what looks like A times B plus C. If we go back, we look and we see, it must be distributive because it has A times B plus C. So we could probably do something like this if we wanted to figure out if something was commutative, distributive, or associative, if this way is still too hard for you to understand. So we know that this is commutative, so therefore A plus B must therefore be equal to B plus A. And we write commutative here. And then we have here the same thing, commutative. Here we have distributive. And then we could also do the same thing here. We have A plus open brackets B plus C. Again, we just substitute in the numbers with letters so we can see if it matches something. So this now is not this up here because this is an addition sign. So let's go back and see what matches A plus B plus C. Here it is. So this falls under associative. A plus B plus C with the brackets. And you see that the brackets can move all over the place. So awesome sauce. So this one is now the associative. Let's look at this one. No, this one is a multiplication sign again, but in here is another different sign. So you realize that for distributive, you would have a multiplication sign and some other operation. Same here, multiplication sign, some other operation. But with the associative law, you would have brackets. Note well that C, D, and E all have brackets. But with D, it has brackets, but all of the operations are the same, which tells us that this is associative. This one has different signs. So we know that we're going to have distributive. It's going to be distributive if we write it out such that it resembles our laws, our examples for the laws, we'll be good. So we have A times 14 represents A, or A represents 14. We have the multiplication sign. B represents 11, and C represents 3. So if you go back, you'll see that this is distributive because it has different signs. Okay, so it matches this. So let's go to distributive and see. Okay, so here we have A times B plus C, and then of course we can have a negative sign in here as well. Just didn't have an example. So this is distributive. Okay, the same thing goes for these. So we have A times open brackets B times C. And so if you look at it, you see that you have the same signs with brackets, the same signs with brackets. And when we talk about same signs, we don't talk about addition and multiplication. Same signs with brackets means that we're dealing with the associative law. So you could try these without me now, and just come back. So this is A times B, which is equivalent to B times A. This is A times open brackets B minus C. And this is indicative of the distributive law, as we can see there. So this is our commutative. And this is our distributive. So you could pause and try this one as well and tell me what you think it is. Identities. The number 0 is called the identity under addition, because when it is added to a number, it leaves it unchanged. For example, 5 plus 0 will give you back 5, and 1 plus 0 will give you back 1. The number 1 is the identity under multiplication, because when it is multiplied to a number, it leaves it unchanged. For example, 5 times 1 is 5, and 2 times 1 is 2. Okay, so let's look at inverses now. Negative 5 is the inverse of 5 under addition, because when the two numbers are added, you get the identity 0. For example, 5 plus negative 5 will be equal to 0, whereas 1 over 5 is the inverse of 5 under multiplication, because the product of the two numbers leave the identity 1. So here we have 5 being multiplied by 1/5, and we show the working to give you 1. Okay? Now it says find the additive inverse of 6, negative 5, 12, a fifth, 4.1, and negative 2 and 3 over 4. So basically you have to ask yourself, what can be added to the number to get an answer of 0? Okay? So to get an answer of 0 for 6, you have to subtract 6 from 6 to get 0. And to get 0 from negative 5, we have to add 5 to get 0. What about 12 and 1/5 and 4.1 and negative 2 3/4. Pause the video and try these questions. Alright, so for 12, you just simply subtract 12. You get 0. Simply subtract a fifth. You get 0 here. Subtract 14.1. You'll also get 0. And then because this is negative, you're going to add it to itself. And you get 0 here. But what about the multiplicative inverse? So what number can be multiplied to the number to get an answer of 1? So whatever number you have here, what can be multiplied? Well, we could multiply 5 by 1 over 5. And remember, a whole number can be placed over 1. Once we cancel out the 5s, we get back 1. The same idea for negative 6. So we will multiply negative 6 by 1 over negative 6. Same idea here, put this over 1. You cancel, you get back 1. Alright, so you can pause the video and try C through F. Awesome. So you should have gotten 17 times 1, 17, 1 over 17. You should have gotten 3 over 2. So you cancel this, 3 cancel it, 2. And you get 1. And we should have gotten here 1 over negative 3.2. These two cancel out, we get 1. And then here we would have gotten, we could make this into an improper fraction. We have 5 times 1 is 5, plus 3 is 8, so we get negative 8 over 5. So we just multiply by 5 over 8, and we make this negative as well. And these will cancel out. And there we have it, we get 1. So I hope you got all of these answers. Okay, so we're moving on to number bases. So when we go from denary or base 10 to another base number, we're just gonna do a simple conversion. Okay, so we're going from base 10 number to other base numbers. You want to ask yourself, what is base 10? Denary is a base 10 number system, also known as decimal. It is a number system most commonly used by people. Each number position contains one of the 10 unique digits of 0 through 9. An example of a denary number would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Why is it called denary? It comes from the Latin word denarius, meaning counting 10. Okay, so we want to convert our base 10 number to a base 4 number. So as you can see here, we set it up just like this, like a ladder. And we want to convert 9 into base 4. So we divide 9. We said 4 into 9 can only go 2 times. And it leaves a remainder of 1. Okay? And then we said 4 into 2. We said 4 into 2 can go no times. And we have a remainder of 2. And the answer will be 21. We read going upwards. Let's try this now. So we want to change 14 to base 4. Now this is the hardest one. This is harder than the other way. So you'll see just now. Changing denary into base 4, base 2, and base 3 is harder than changing base 4, base 3, base 2 into denary. So let's try this. So here we have 14. And we say 4 can go into 14 3 times. So we put 3 here. 3 times 4 is 12. And 14 minus 12, you have a remainder of 2. You put the 4 here. 4 goes into 3 0 times. It can't. So we put the 0 here. And we have a remainder of 3. And if we read going up, we see that the answer is 32. So 14 in base 4 is 32. So let's try, and we got the answer here. Let's try 16. I'll leave you to try 16 now. changing 16 into base 4. So let's try it now. We're going to draw our little ladder. And we're going to put our 4 outside and our 16 here. 4 goes into 16 4 times. We place it down here. And we have a remainder of 0. 4 goes into 4 once. And we have a remainder of, again, 0. So these correspond. Remainder 0. 4 cannot go into 1 anymore. It cannot go into, 4 cannot go into 1. So it has a remainder of 1. So it cannot go into 1, so that's 0 times. And so therefore it has a remainder of 1. So reading upwards, we'll have an answer of 100. Okay, here are some for you to try. Okay, again, remember when you divide in 24 by 4, you do the same routine. 4 into 24 goes 6 times, and it's a remainder of 0 because 4 times 6 is 24. So remainder of 0. Now 4 into 6 goes once, you have a remainder of 2, and they're all related. And then 4 into 1 cannot go, so it's 0, and it's a remainder of 1. Answer is 120. So I'll give you a go at this, try this, and then I'll do 2 and 3 for you and show the answers. Great, nice try. So let's go and see what you have. So again, we want to go into base 4, so 4 into 61. How many times can 4 go into 61? Use a calculator. It's a 61 divided by 4, and you get 15 times. So since it goes in 15 times, we know it has a remainder. So 4 times 15 gives us 60, and it has a remainder of 1. Okay? And so we want to see how many times 4 can go into 16. 4 can go into 4 can go into 15 3 times now. And we know that 4 times 3 is 12 with a remainder of 2. Then we see, can 4 go into 3? No. 4 cannot go into 3, so we have 0 times. It can't go into 3. 0 times. So the remainder would be 3. And therefore our answer would be 321. Cool. Now note well that the calculation ends when you reach to 0. Let's try number 3 together now. How many times can 4 go into 83? Use the calculator, and we see that 4 can go into 83 20 times. 4 times 20 is 80. So 80 from 83 has a remainder of 3. Can 4 go into 20? Absolutely. So we get it going in 5 times with a remainder of 0, because 4 times 5 is 20. Can 4 go into 5? Yes, it can go into 5 once with a remainder of 1. And then here we have 4. Can 4 go into 1? No. 0 times with a remainder of 1. So the answer for this would be 1103. Okay, so I hope that all of this worked out well for you, and you should have gotten answers of 3, 3, 3, 3, and 10,000 here for 256. Okay, now so we have something new where we're going to change from base 10 to base 2. We're going into binary. So again, all we do is the same thing, same idea. Can 2 go into 3? Once with a remainder of 1. Can 2 go into 1? No, 0. So we have a remainder of 1. So the answer going from bottom to top would be 1 by 1. Now with binary, you would only ever get answers of 1s and 0s. If you start to get answers that include 3, the number 3, 4, 5, 6, anything other than a 1 or 0, you would know that you're going wrong. So let's try 4 now. And we see here that 2 can go into 4 twice with a remainder of 0, because 2 times 2 is 4 and 4 minus 4 is equal to 0. So we have a remainder of 0. And then we see that 2 can go into 2 once. And we have a remainder of 0, because 2 times 1 is 2. So remainder of 0. So and 2 minus 2 is 0. And then we see here that 2 cannot go into 0, so we end up with a 0 down here. And so our remainder will come from here, equal to 1. So our answer for this would be 1, 0, 0. You could pause the video and try to do 5 and 6. Two into 5 goes twice. 2 times 2 is 4. And so 5 minus 4 will be equal to 1. Okay, so 2 into 5 goes 2 times. And so we know 2 times 2 is 4. So 5 minus 4 is a remainder of 1. Okay? Then we put the 2 here again. 2 into 2 goes once. And we see that 2 times 1 is 2. So 2 minus 2 equals to 0. So we have a remainder of 0. And when we said 2 into 1, it goes 0 times, and this comes down. So we have a remainder of 1. So this one comes down, remainder of 1. And so the answer will be 1, 0, 1. So we're going up like that. Let's try this one now. Alright, so we're going to do now 6. 2 into 6 goes 3 times. And we said 2 times 3 is 6. So 6 minus 6 will give a remainder of 0. Okay? Then we said 2 into 3 goes once. So 2 times 1 is 2. So 3 minus 2 is equal to 1. That's our remainder right there of 1. 2 into 1 cannot happen. So then we have a remainder of 1. So the answer would be 1, 1, 0. When we want to change from any base number to denary, it's much easier. All you have to do is write out the number. And so this tells us that this is 11 base 4. Okay? And this is pretty much saying, this is how it goes. So you will start from the ones and move to the left. And you will say 4 raised to the power of 0. Then 4 raised to the power of 1. And then as the numbers increase, you just say 4 raised to the power of 2, 4 raised to the power. So that's what will happen. This is 4. That's where you get these numbers. 1, 4, 16. 4 raised to the power of 0 is 1. 4 raised to the power of 1 is 4. 4 raised to the power of 2 is 16. Right? Same thing here. And look, as we move here, this will be 4 raised to the power of 2. This is 4 raised to the power of 3, which is 64. And then all you would do now is add up the numbers to give you your number in denary. So this is much easier than converting from denary to some other base. When you convert a base to so this is much easier. When you are converting from a denary to a base number, you have to do a series of divisions. Whereas when you're converting between a base into denary, you just do a series of multiplications. So this one dealt with base 4, as you could see here. Base 2. Base 2 has the same idea. Again, this would be 2 raised to the power of 0, 2 raised to the power of 2, 2 raised to the power of 1, 2 raised to the power of 2, and then 2 raised to the power of 3. Same idea here, same idea here, and then you would just add. So let's try this. So this is base 2 being transferred, well, any base being converted to denary. Here we have base 2, base 2, base 4, base 4, base 4, base 2. And since it's so easy, I'll do B and C and hope for the best with you, D, E, and F, okay? So here we have 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And you get 8 plus 4 plus 2 plus 0 plus 1. 8 plus 4 is 12 plus 1 is 13. So the denary number of 1101 base 2 is 13. And here we have this one now. We're going from base 4 to denary. We have 16 times 3 plus 4 times 3 plus 1 times 0. And from this we get 48 plus 12 plus 0. 48 plus 12 plus 0 gives us 60. And pretty much you could work these out and pause the video. Binary numbers. A binary number is a number expressed in the base 2 numeral system or binary numeral system. It is a method of mathematical expression which uses only two symbols, 0 and 1. Each bit is referred to as a bit or binary digit. When adding binary numbers, just know that 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, and 1 plus 1 will be equal to 0, 1, or 1, 0. So for this one, you basically have 1 plus 1 is 0, and then you carry the 1 and bring down the 1 here, okay? So it'll be 1, 0. That's all you need to know. So knowing that, after you've written down your notes, we could try these questions. We say 1 plus 0, let me do 1 and A and B for you, and then you could try C and D. So let's say we have 1 and 0. Remember, we know that 1 and 0 brings back 1. So 1 and 0 brings back 1. And we look over here, we see that 1 and 1 gives you 0, 1. So we have the 0 here and put the 1 here. So that would be your answer. Okay, let's try B. We know 1 and 1 brings back 0, 1. If you're writing from right to left. So we have 0 and put the 1 up here. Now we have again 1 and 1. So we have 0, carry the 1, that's supposed to be, and again 1 and 1. So we're going to have 0 and bring down the 1 finally. And that'll be your answer for this one. Okay, so you could try C, D, and E. Pretty much for here, what's happening is that we have, well, here we have 1 plus 1. 1 plus 1 is 0, 1. So we have the 0, we carry the 1. Okay? We also know that 1 plus 1 is 0. So we have 1 plus 1, that will give us 0, 1. So we carry the 1. So remember, 1 plus 1 will give us 0. And we bring back the 1, right? So we have this 1 here to contend with. So bring the 0 and we carry this 1. Again, we have 1 plus 1, which is 0, 1. but this 0 is going to add to the 1 here. So we have 1 here. We carry the 1 that was from here. Okay? So we had 0, these two made 0. We carry the 1 here. But this had a 1, so 1 plus 0 gives you 1. And again, 1 plus 0 gives you 1. And so now we again have 1 plus 1, which is 0, carry the 1. So that was the most complicated one out of the set. When subtracting binary numbers, 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. And then if we have a 0 subtracting 1, we'll have to borrow this 1, make this 0, and this will now become 2. So then we said 2 minus 1 will give us 1. The reason why 1, 0 is made into 2 when we are borrowing is because 1, 0 converted from binary into denary is actually equal to the number 2. 1 minus 0, like over here says, it gives you back 1. And then if we have 0 minus 1, we have to borrow that 1. We have 0 here. And now we'll say 2 minus 1 is 1. Same thing here, 1 minus 0 is 1. And if you have a 2 here, we have to borrow from here, where we have a 0. We get 0 right here. We get 0 right here now. And so we said 2 minus 1 is 1. Now, because we have a 0 here again, we have to borrow from this 1. Here will be 0. And this 1 will be 2. So we said 2 minus 1 will give us 1. Look at this as well. So I'll write it out here so we could see it properly. 0 minus 1, you can't do it. So what we want to do is borrow. We can't borrow from here. So we borrow here 0. And this now will become 2. Again, we need to borrow. So we're borrowing from this. This will become 1, and this will now become 2. So 2 subtract 1 will be 1. We bring down the 1, and we have 0 and then 1. And that will be our answer for this. Okay? That's pretty much how it goes. So let's try these together now. We know that 1 plus 1 is 0. We carry the 1 up here. 1 plus 1 is 0, 1. Carry the 1 up here. And then we get to bring down the 1 finally, because it has nowhere else to go but down. Then here we have the addition. We say 0 plus 0 gives us 0. And then 1 plus 1 will give us 0, then 1. And then now we have our famous subtractions. 1 minus 0 gives us 1. But 0 minus 1 is a problem. So because we can't borrow from this, we have to borrow from this. We're going to bring it over here. But then we're going to borrow from this and put it here. So 2 from 1, well, 1 from 2 will give us 1. And then we just bring down this 1, and we have the 0 here. Let's try this. 1 minus 0 gives us 1. And then we would now have to borrow. So we're going to borrow from here. And we have 2. So 2 minus 1 gives us 1. And we're going to borrow from here. And then we're going to cross this out. We get 2. So 2 minus 1 gives us 1. Put the 0 down here. And we are good to go. Alright, so now we're going to be looking at ratios. A ratio compares the sizes of 2 or more quantities. Ratios may be written as fractions. For example, number of girls divided by number of boys equal to 4 over 3. Or you could write it with a colon between the two numbers to express girls as opposed to boys. Like fractions, ratios can be simplified by multiplication or division by a common factor. So look, we have 8 colon 12. This could be brought down to 2 and 3. 9 to 12, 3 to 4, and then 18 to 6. We could get 3 to 1. So we just look for a common factor that they can be divided by. Okay? These are some things you should note. Write them down in your books so that you have them forever. Note that 1 meter is equivalent to 100 centimeters. 1 meter is also equivalent to 1,000 millimeters. 1 centimeter is equivalent to 10 millimeters. 1 kilometer is equivalent to 1,000 meters. 1 kilometer is equal to 100,000 centimeters. 1 kilogram is equal to 1,000 grams. 1 liter is equal to 1,000 centimeters cubed. 1 liter is also equal to 1,000 milliliters. 1 centimeter cubed is equal to 1 milliliter. And then we have our conversions right here. So to go from 1 meter to centimeters, you'd multiply by 100, sorry. So to go from meters to centimeters, you multiply by 100, and then to go vice versa, you just divide. To go from meters to millimeters, you multiply by 1,000, and vice versa, millimeters to meters, you divide by 1,000. And you see the trend here. To go, you see how to convert. You see how to convert between them by looking at these on top of the arrows. So write them down in your books, and then we'll get started. Alright, so here we have 15 centimeters is equivalent to 1 meter. You want to find a common unit. So this is what we call a unit, a form of expression measurement. So a unit is a form of expressing measurement. And so we could often we could actually compare centimeters, or we could go into 15 centimeters is indeed equivalent to 100 centimeters, like what we saw over here. It says 1 meter is equal to 100 centimeters. And so we converted the 1 meter to 100 centimeters. So we see 15 is equivalent to 100, and the units can cancel now. And we see this can be brought down to 3 and 20. Okay, I guess 5 can go into 15 3 times, and 5 into 100 20 times. And this is the trend right here that we see. We see 20 centimeters to meters. We convert this to centimeters, and we get 20 to 200, which breaks down to 1 and a 10, a 1 to 10 ratio. And here we have 1 kilogram to 400 grams, so we want to change the kilograms to grams. So basically, you want to change the kilograms into grams, because if you change the grams into kilograms, it'll be ending up into you'll end up having a decimal point of 0.4. So we want whole numbers. Here we have 1,000 to 400, and we end up with 5 to 2. Let's try 2 liters to 500 milliliters. So let's look at the liters. It says here that 1 liter is equal to 1,000 cubic centimeters. So to go from liters to centimeters, we have to multiply by 1,000. It says it right here. And so 2 times 1,000 gives us 2,000 milliliters. And we have here 500 milliliters. And we could start to slough off zeros, where we have 22, 5. And this will give us 5 into itself once, and 5 into 24 times, so 4 to 1. We have 30 millimeters to 6 centimeters. So let's see which one's going to give us a whole number. So if we want to go from centimeter to millimeter, we can multiply by 10. So this is what we're looking at right here. And we can multiply by 10. So this will give us 60 millimeters. And we have 30 millimeters. So this could cancel out, and the zeros cancel out. Then we see that 3 can go into itself once, and 3 can go into 6 twice. So it's a 1 to 2 ratio. Okay, and look at this now. We have 5 millimeters and 6 meters. So millimeters is smaller than 6 meters, and we know that millimeters can go into the meters. So we're going to just convert the meters. So when we have meters now, we want to convert meters to millimeters. So to go from meters to millimeters, we just multiply by 1,000. and we say we have 6,000 millimeters, and then we have 5. We could get rid of the units. And we see that 5 can go into self once. And seeing as how this it ends off with 0, 5 can go into this. 5 can go into 60 12 times. And then we have 1200. So 1 to 1200. And that's pretty much it. So you could try your hands at these. This is simpler. So this is simpler right here. It says, write these ratios in their simplest forms. So we already have 1. We have 15, 40, 60. And we end up with 3, 8, 12. So try 18, 24, 36. 48, 72, 112. And 35, 49, 3, 43. Pause the video to try it. Great. So you can see that 6 can go into all of these numbers for B. And then 7 went into all of these numbers for D. And then for this one, it seems as though 8 went into all of these numbers. So basically you're looking for the highest common factor to bring down your ratios to smaller amounts. Proportion. A proportion tells you what fraction of the whole quantity is. For example, if the ratio of sunny to cloudy days in November is 1 to 4, then the proportion of sunny days in November is 1 over 5, while the proportion of cloudy days is 4 over 5. Sunny to cloudy days, we have 1 to 4. And we add these numbers to give us the whole. So we have 1/5, 4/5. Let's try this one. The ratio of boys to girls in a school is 4 to 5. How many boys are in the school if there are 900 students? So again, we write it out. We have boys to girls. We have a 4 to 5 ratio. So therefore, 4 plus 5 will be equal to, good, 9. And then you're going to now write 4/9 and 5/9 here. Since we know the total of boys and girls is 900, we can find the fraction of that 900, which is 4 over 9 times 900. 9 into 900 is 100, and that will give us 400 boys. And that's how you do that. There we go. And if you wanted to know how many girls there are, you would simply subtract 400 from 9 to give you 500 girls. Or you can do the calculation you see there. That's it, students. Thanks for watching.